Hello everyone, in this short video we're going to find the derivative of a function that included denominator. So this is not really rational functions. We cannot call this one rational functions because in the numerator we have only a constant. So we can rewrite our functions in this format, minus 6 times t plus 6 power negative 4. Okay, so when we write it like this, so we now gonna use a chain rule. So chain rule, remember what the chain rules tell us. If we have, if they ask us to find the derivative of u power n, so to find the derivative, you bring the u in the front times u n minus 1 times u prime. So that's what we're gonna do. In this particular examples, let's say u for us is simply t plus 6. What is u prime? U prime is 1. So we're gonna have y prime would be, remember the negative 6, we're gonna keep it outside. Now bring the exponent in the front, keep your u as is. Now exponent minus 1 times the derivative of u. So I think we can put it in the inside times the derivative of u, which is simply 1. Now we see that y prime would be negative 4, 6 negative 4 give us positive 24 times t plus 6 power negative 5 times 1, so equal to itself. Now we can simply rewrite our derivative as y prime equal 24 over t plus 6 power 5, because we don't want to write down the final answer with a negative exponent. I think that was all. This example is just to show you that not all the function that has a numerator and a denominator can considered directly as a rational functions when you need to find the derivative of that function. So you can bring your denominator up there in the top, just changing the exponent. But at some point, if we had some variables also in the numerator, it could be totally different. We could consider it as a rational functions. Even though if you do both methods, if you want to do that quotient rule, it will also work. Hope you can use this example to do more. Don't forget to subscribe for more videos. I'll see you soon.